4 and 2 are brought together. Okay, lads. Kilogram go. Impinge obliquely. The 2 kilogram mass is brought to rest by the impact when the coefficient of fusion is enhanced. Brought to rest. Alright. Only one way that's getting brought to rest. Okay, so if that's A and that's B, and I don't know if that's going left or right. It doesn't really matter. If I'm wrong, C is negative, and if I'm wrong, D is negative as well. Okay. Oh, sorry. Yeah, yeah. Got to get there. You beat me to it. The fact that the all right, the fact that the 2 kilogram mass is brought to rest means two things. C is actually going in the opposite. C is negative. Would you agree with that? It has to be on left. And D is 0 because if it's brought to rest, it means that the J component was already 0. Okay, so that all that's been established. Any questions so far? Good. All right, let's do the after collision then. And the after collision will be. All right, 4 kilogram mass, and A no longer exists, so something else exists. I don't know. Use this as D, and this can be 0 and 0, and that is still B. Prove that before the impact, spheres were moving in directions perpendicular to one another. All right, no bother. Let's just get V1, V2. See what happens. Okay, we're going to use conservation of momentum. 4A plus 2C. We know C is negative, but it doesn't matter. And then 4D, 2 times 0. Okay, what we establish is that 4A plus 2C equals 4D, or 2A plus C equals 2D. Next, we're going to go with Newton's experimental law. Oh, sorry. V1 minus V2 equals minus E into U1 2. Okay, and our E is a half. Minus a half. Now it's going to be A minus C here. And then V is going to be D minus 0. Okay, let's rearrange this. I'm going to cross multiply up that 2. So I'm going to get 2D minus A plus C. Now, it appears I have two simultaneous equations with 3 letters. Okay, so 2 simultaneous equations with 3 letters. So the real question is, what letter do I want in terms of what? Do I want A in terms of E? What do I want from this? Okay, is what I need to look back at. So I want to prove that they're moving, that before impact, the spheres are moving directly perpendicular to each other. This means A has to be 0, doesn't it? Read the language. If the 2 kilogram particle is moving directly to the left or directly to the right, it means that the 4 kilogram particle must be either moving directly down or directly up, one or the other. Essentially, if I prove A equals 0, they're perpendicular to each other. That makes sense? My job is to isolate A and prove it equals 0. That is my job. All right. So what I'm going to do is going to rearrange this underneath. So it's going to be the top equation, 2A plus C equals 2D. I'm going to multiply this one by -1, and I'm going to get A minus C equals minus 2D. And lo and behold, the maths doesn't lie. 3A equals 0, A equals 0. They were moving perpendicular to each other because one of them only, you might write yourself a little note here. BJ. One of them only has an I component, the other one only has a J component. Alright. What does it want from me in the next part? Show that the kinetic energy gained by the 4 kilogram mass is equal to half to that lost by the 2 kilogram mass. Ouch. Alrighty. It might be worth getting C in terms of D or D in terms of C. One or the other. So just while I'm here, I've established that A equals 0. And what I'm going to do is I'm going to sub it back in. So I'm going to get C equals 2. C equals 2D as well. Okay, I might need that later on. So I'm going to rub all this out. Can I rub it out or good? Now, here's what we're going to do next. Get rid of this here as well. Now let's go back. Of all the information I need in this little corner here. Show that the kinetic energy gained by the 4 kilogram mass is equal to half of that lost by the 2 kilogram mass. Okay. So let's think about this. We know that A is 0. So what's the kinetic energy gained by the 4 kilogram mass? Alright. Kinetic energy of the 4 kilogram particle before the collision. So half mv squared, yeah. And what else can it be? So ke before is going to be a half times 4 kilograms times b squared. Alright, you guys? And what we get there is 2b squared is how much I had before the collision. Okay. Now let's do that's the 4 kilogram before the collision. Let's do the 2 kilogram before the collision as well. 2 kilogram before is going to be a half 2 c squared. So half 2 times c squared is c squared. Alright? So kinetic energy of 2 kilogram before collision is c squared. Kinetic energy of the 4 kilogram before the collision is 2b squared. Yes? Why didn't I use the j component? Why did I only use the j component? So kinetic energy is, for example, is this, right? Imagine you're moving across for an up tree and you have a hypotenuse of 5. Yeah? And let's say your particle is of weight 2 kilograms. Yeah? I would do a half mv squared, a half 2 times 5 squared, because 5 is its velocity. But in this case, imagine you have no I component and only a j component. Then your speed is 3. You don't have to do Pythagoras' theorem because you only have one component. So it'll be half 2 times 3 squared. Did I explain it all right? Yeah. All right. So in this case, both of them only have one component each. You get what I'm saying? They both only have one component each. Yes. Yeah, I just actually thought of that this second. Yes, but I'll just work it all out, and you will find you'll probably find that you can just leave the j component out anyway. Okay. Yeah, correct. So your way's faster and better. All right. Now, next thing we're going to do K after. Okay. Now this one has D and B combined, doesn't it? Okay. So he was correct in saying that you're going to use, so if I have D and B, so I'm just going to go through this again. If I have what's a D across and B up, yeah? What's the hypotenuse going to be? Buddy? X squared equals D squared plus D squared. Like, I'm completely wasting time right now, but I'd just like to show why it happens. Are we cool with that? Right, that's its velocity. Okay, so that's its speed. So that's what I'm going to use. So it's after the collision, it's going to be a half its mass times the square root of what's a d squared plus b squared squared. Okay. The kinetic energy of the 2 kilogram particle after collision is going to be a half. Oh, it's gone. Isn't that right? It's not moving, is it? 2 kilogram particle is not moving. It has no. It has no. What's that word? It has no velocity left. Okay. Now, what we're going to have to do is we're going to have to compare the 4 kilo. Look at the writing. How much did it gain? Okay, is what we're looking at. So we need to compare the kinetic energy of the 4 kilogram particle before the collision compared to it after the collision. So after the collision, it will look like this. A half times 4 is 2. And then it's going to be 2 times d squared plus b squared, which is 2d squared plus 2b squared. And what he said has come true. Why didn't you just ignore the j components in the first place? They stay the same. 2b squared belongs to the j components. The 2b squared still belongs to the j components, which means you only gained 2d squared in the I direction. Okay? So it's because you weren't moving left and right before the collision, and now you are, you now have kinetic energy in the I direction as well. Okay? So this means that when you compare this one here to this one here, the kinetic energy gained is equal to Ke gains is equal to 2d squared. Now, when you're talking about the smaller particle, how much did it lose? It had c squared at the beginning, and now it has nothing. So how much did you lose? You lost c squared. Okay. Now this is where this comes in handy. Remember we had earlier on. Remember we had this little nugget here. C equals 2d. Now we can directly compare them. C squared is 2d 2b squared 4d squared lost versus 2d squared gained. You can see that that's half as much, isn't it? And that's what they were looking for. You may have to go over that again. But, try question 10 now.